Hi, welcome back. Today we're going to be looking at the forces questions from this grade 12 paper. Question 1.1 is the multiple choice question which reads a constant net force acts on an object moving in a straight line. So constant net force, okay. So we have F net equals MA. So constant net force. Which one of the following quantities associated with the object will remain constant during the motion? So we know from Newton's second law, if there is a net force acting on an object, the object is going to accelerate. Now we know that acceleration is equal to the change in velocity divided by time. So the velocity is going to change, right? So if velocity changes, that's out. We know that momentum is equal to mass times velocity. So if velocity is changing, momentum is also going to change. We also know that kinetic energy, EK, is equal to half mv squared. If velocity is changing, it means that EK is going to change. So the only option left is acceleration. The answer is C. Okay, let's move on. Question number 2. An 8 kilogram block on a rough horizontal surface is connected to a 2 kilogram block by a light inextensible string passing over a frictionless pulley, as shown below. The 8 kilogram block moves at a constant speed. So that's in bold, so it must be important. What does that mean? So constant speed means that acceleration is 0, and that means that F net is 0. When pulled by a 29.6 Newton horizontal force to the right, the frictional force acting on the 8 kilogram block is 10 newtons. Definitions, we leave them out. Question 2.2, draw a labeled free body diagram for the 8 kilogram block. Okay, so question 2.2, for this 8 kilogram block, there is going to be a force of gravity that's going straight down. There's also going to be a normal force since it's resting on a table. There's going to be a force applied. And there's going to be a tension force since it's connected to a rope. And the last one is that there's going to be a frictional force to the left parallel to the surface since the object is moving to the right. So 5 marks, 5 forces. Question 2.3, calculate the tension in the string. So we can say that since the object is not moving up or down, we just need to consider the forces going left and right. Now we can say that F net equals MA. And just remember, we're focusing on the 8 kilogram block. F net equals MA. If we choose right as positive, we're going to have FA minus friction minus tension is going to equal to 0. Remember, we said at the beginning, F net is 0 if it's a constant speed. Now we know FA is 29.6. We know friction is 10. Then minus tension is equal to 0. That means that 19.6 newtons is equal to tension. So a 3-mark question, you get a mark for formula, for substituting, and for your answer. Okay, let's move on. Question 2. They give us some information. The 29.6 Newton horizontal force is now increased to 15 newtons. Apply Newton's second law to each block and calculate the magnitude of the acceleration of the 8 kilogram block. Okay, so they tell us that we need to use Newton's second law for both, which means that we need to use simultaneous equations. So let's draw a free body diagram for the 2 kilogram block. For the 2 kilogram block, there's going to be Fg pointing down and tension going up. Since it's moving, the whole system is moving in that direction, and we chose right as positive, it means that for this movement, up will be positive. Okay, now we can apply Newton's second law to each. Now let's say for the 2 kilogram block, this is question 2.4.1, we'll say F net equals MA, tension minus Fg is equal to MA. We can now simplify, we know what Fg is. So T minus Fg is mass, so 2 multiplied by gravity, 9.8, is equal to 2 times A. That means we can simplify. T is equal to 2a plus, what is it, 19,6. Okay. Now we'll do the same thing, but for the 8 kilogram block. Oh, and it's important that you remember that the tension now is not going to be the same. So we can't use the same tension value in the previous, as we calculated in the previous question. Okay. Now for the 8 kilogram block, we'll do again F net equal MA. Right? Same thing as before. We're going to have FA minus F minus T. So FA minus F minus T is equal to, now it's not 0 because it's not constant speed anymore, there's acceleration. So it's going to be 8A. Let's simplify. Now the force applied is 50, the friction is still 10, minus T equals 8A. That means we can then simplify, we can say 40 minus 8A is equal to T. Now we know that the tension is going to be the same in both, so we can equate. So we can equate tension equals tension. That means 2A plus 19,6 is equal to 40 minus 8A. We can then take the minus 8A over. We'll get 10A equals 20,4. That means A is equal to 2,04 meters per second squared. Now they ask for magnitude, so we do not need to give the direction. Okay, let's solve the last question. The last question says, calculate the tension in the string. So once we have the acceleration, we can substitute it in either one of the equations. We can substitute it in either this equation if we want, or that equation. Both will give us the same answer. So let's use the first one. So T is equal to 2A plus 19,6. We've worked out A, so 2 into 2,04 plus 19,6. That means the tension is then equal to 23,68 newtons. Okay, that's it for this section, for this paper. If you found it useful or you found it helpful, please leave a like, share, subscribe it with your friends. If there's something specific you'd like me to go over, please let me know in the comments below. And I'll see you in the next one. Bye-bye.